Hey, Year Sevens, we're back again today with a little bit more of angle theory, starting in with angles in a full turn today. Now, I know this is another rule that you learned last year, so today, once again, we are focusing more on the method, setting up and solving equations, rather than just what the angle is. So even if you know what the answer is, don't guess at it, don't skip any steps. Let's show all of our working, please. All right, let's get started. First of all, angles in a full turn. How do you measure angles in a full turn? Because here I've got a protractor and it only goes from 0 up to 180. What is a full turn? Well, it would help if we had a point to start with so that we could measure the angles around that point. So here's my little red point here. It would also help if I started with a straight line from that point so I could line my protractor up at 0 on that line and measure all the way around until I get back to that line and see what that angle is. So here I've got my protractor lined up so that the center of the protractor is here at the red little point, so I know what the angle is around that point. And the side of my protractor has got lined up on 0 on this blue line so that I can start here at 0 and measure around until I do a full turn. Now my protractor is not big enough to measure a full turn, so what I tend to do is draw this little dotted line here out to the side, which is making 180 degrees so that I know where to start when I turn my protractor around. So here I've turned my protractor around, and starting from over here on 0, I'm measuring all the way around another straight line, or the other side of that straight line, to 180 degrees. So altogether, I've measured 180 degrees on the top and 180 degrees on the bottom. Together, that makes 360 degrees, all the way around a full turn around that one red point. Okay, so let's get started using this fact here with this first example. And it's a very practical example because when you're asked to measure a reflex angle, as you see with my protractor, it only goes to 180, so it's difficult to measure angles that are bigger than 180. So we'll use the facts about angles in a full turn to measure this reflex angle. I can see that this angle around that point there is made out of this reflex angle and an acute angle. So I'm going to take my protractor and measure that acute angle instead. And I can see that that protractor lined up with the center on the angle and 0 on one line. I open up until I see the next line is at 70 degrees. So I can see that that is a 70-degree angle. Knowing that the reflex angle and that 70-degree angle, that acute angle, will make a full turn, I can use some algebra, write an equation, and solve it to find out what my reflex angle is. Then I don't have to mess around with turning my protractor around and trying to measure that. So I'm going to call this reflex angle x, and I'm going to write an equation using the rule that angles in a full turn add to 360. So I've written my rule and I've written my equation. X being my reflex angle, and 70 add to make 360 degrees because it's a full turn. Now I can use my algebraic methods to rearrange this equation to find out what the unknown variable is. That's to find out what x, my reflex angle, is. So I want to get the x by itself, which means I'm going to need to get rid of this 70. I'll send it over to the other side. Here I'm adding, so to get rid of it, I'll subtract it. So I'll have x equals 360 minus the 70. Okay, so x is just going to be 290 then. I found my reflex angle and I didn't have to mess around with my protractor to measure an angle that's bigger than 180 degrees. Reflex angle, 290. All right, let's go on to the next example. Again, we're not going to be using a protractor at all for this. This diagram is not drawn to scale. So we just need to use algebra, use the rules that we know, and rearrange our equation to solve. So here we can see that x and 260 form a full turn around that red point, and that much is clear. There's no way that that's less than 360 or more than 360 because it's a full turn around a single point. So we'll write the rule and write the equation. The rule for this exercise will always be angles about a full turn, and the equation will always be something adds up to 360. So in this case, we've got x plus 260 equals 360. So I'm going to rearrange that equation to find out the unknown variable, find out what x is by getting it alone. So x on its own would be equal to 360 minus the 260. It was plus 260 on this side. On that side, it's minus 260. And like we said before, the order is important. The 360 degree was here first. I'm not going to write 260 minus 360. 260 comes after the 360. Okay, 360 minus 260 is positive 100, so x is 100 degrees. That's it. Next example. Here we see three angles which form a full turn around that red point. See, I've got angle x, I've got this little square here, and we should know that when you put a little square in the place of an angle, that's 90 degrees, and then I've got 110 degrees. So I know that x plus 90 plus 110 will add up to 360 degrees because it's a full turn. So let's write the rule and write the equation. A full turn, so these angles have to add up to 360. X plus 90 plus 110 equals 360. Now I'm going to rearrange this equation to find the unknown variable. I'm going to figure out what x is by getting it on its own. First, I'll simplify this. 90 and 110, that makes 200. So x plus 200 is 360. And now getting x on its own, I'll send the 200 to the other side. X equals 360 minus 200, which leaves me with x equals 160. Okay, so we're ready to start the exercise now. Remember, we're following the same basic steps as last lesson. You always need to copy the diagram and label it with all of the angles that you're given and all of the variables that you're going to use. Then you write the rule, and for this exercise, we're talking about the angles on a full turn. But this is important because later we're going to be doing mixed exercises where you'll have full turns, triangles, straight lines, parallel lines. We'll have all sorts of rules, and we want to make sure that we're clear about what we're doing. So write the rule, angles on a full turn, write the equation. For the angles on a full turn, it's always something adds up to 360, and solve the equation to find the value of the unknown variable. Now, we didn't have any of these examples this time, but remember, it's always important to reread your question to make sure that you are done. Sometimes they will ask you to find out what's the value of the variable, so what is x, and sometimes they'll ask you to find out what the angle is, in which case maybe the angle is 2x or 3x or 20 minus x, so that time you're going to have to do a little bit more working. Okay, so hopefully this is all clear. If you need to go through it again and finish off your notes, please do that before you start the exercise. Otherwise, good luck with it and just let me know if you need any help. Okay, have a good day.